Welcome to this explainer. Today, we're going to definitively trace the history of Earth's climate so we can truly understand our current reality. I'm absolutely thrilled to walk you through this material because we're going to look at the exact data that scientists use to track the timeline of our planet. By zooming all the way out and then bringing it right into the present day, we can separate fact from fiction. So let's just dive right in by asking the core question at the heart of this entire topic. Is climate change just a natural cycle? I mean, you hear this all the time, right? Well, to figure out if what we're experiencing right now is just Earth doing its normal thing, or if it's something entirely unprecedented, we need to look at the deep, deep historical data. To answer that, we're going to use this macro to micro zoom roadmap. We'll start with Section 1, Weather versus Climate. Then Section 2, the Quaternary period. Section 3, Ice Age cycles. Section 4, the last century. And finally, Section 5, our current reality.
All right, Section 1, Weather versus Climate. We've got to establish our baseline metric first.
Look, the crucial point here is that a one-off extreme storm, that is just weather. It's what you see outside your window today. But true climate change requires a long-term shift, and that's measured over at least 30 years. When we talk about global climate change, we aren't talking about a single hot summer. We're talking about massive, global-scale changes sustained over 3 decades or more.
Section 2, the Quaternary period. Let's start our macro view by traveling way back about 2.6 million years. We are currently living in the Quaternary period, which is broadly categorized as a historically cold chapter in Earth's deep 4.5 billion year history. It kicked off 2.6 million years ago. So, right off the bat, our baseline for the era of human evolution is actually a relatively cold planet. Now, what's really interesting about this visual is how clearly it maps the cooling temperatures leading into and during this period. Starting on the far left, you'll see the climate was relatively warm 5.5 million years ago. But as your eyes move to the right, toward the 0 mark representing today, you can visually trace the planet slipping into this deep chill. Breaking this down, we see an undeniable cooling trend, evidenced by temperatures dropping drastically over millions of years. Between 5.4 and 3.5 million years ago, temps were just 1 degree Celsius above present day. But flash forward to 600,000 years ago, they plummeted to 9 degrees below. And the most crucial takeaway here is that these temperature swings actually became much more extreme over time. Early on, the planet was only fluctuating by about 1 degree, but later, Earth started seeing these massive 9-degree oscillations. Section 3, Ice Age cycles. Let's see how this builds as we zoom in from millions of years down to hundreds of thousands of years. During those extreme temperature swings we just talked about, the Earth entered glacial periods. Basically, these were massive, 90,000-year deep freezes. When temperatures dropped, land-based ice sheets expanded massively across the globe, locking up the Earth's water and causing global sea levels to plummet. But these were punctuated by much shorter 10,000-year warm windows called interglacial periods. The ice sheets would melt and global sea levels would rise again. Fun fact, we're actually living in an interglacial period right now. It's called the Holocene, and it started about 11,700 years ago. This brilliantly illustrates that rhythmic, natural heartbeat of the planet, cycling between deep freezes and quick warm-ups over the last 500,000 years. Notice those sharp peaks? Those are our brief 10,000-year warm periods. And the deep, wide valleys? Those are the brutal 90,000-year ice ages. When we analyze this cycle, the trend is unmistakably regular. Nature operates on a very distinct schedule here. The evidence shows massive historical shifts of up to 13 degrees between the highest peaks and lowest valleys. Notably, while glacial periods end abruptly, they cool very slowly. But what is absolutely vital to note is that our current Holocene period has been remarkably stable for nearly 12,000 years. This long, stable warmth is exactly what allowed human civilization to flourish in the first place.
Section 4, the last century. We've established that the climate changes naturally over vast stretches of time. But brace yourselves as we zoom in on the last 100 years. Look at how violently this recent data breaks the slow 90,000-year natural cycles we just analyzed. There is no slow tens of thousands of years cycle here. It's an immediate, shocking launch straight upward.
The trend here is literally a vertical spike, evidenced by 2024 completely shattering records at over 1.5 degrees Celsius, warmer than the pre-industrial average. And the most notable feature? Almost all of this drastic climb happened in just the last 40 years. Remember how true climate change requires a 30-year metric? Well, a 40-year uninterrupted vertical climb easily qualifies, and it completely defies the natural historical pace. Which brings us to Section 5, our current reality. So what does this unprecedented, unnatural 40-year temperature spike look like for us on the ground today? As this NOAA heat map shows, it means that the 10 warmest years on record have all occurred since 2010. Let that sink in. We are looking at nearly half a century of temperatures consistently above the 20th century average. All those dark red areas on the map, that shows regions baking in unprecedented heat. To bring this global data a bit more local, in 2022, the UK's annual average temperature shattered a historic milestone, passing 10 degrees Celsius for the very first time. Now, 10 degrees might not sound like a blistering beach day, but as an annual national average, it's staggering. You can see on this Met Office chart how that record fits into a clear, aggressive upward pattern. It doesn't just bump up, it shoots straight through that 10-degree ceiling that had never been breached in recorded history. Ultimately, those abstract charts translate into a very visceral reality: scorched earth and drastically altered local environments. This completely dried out brown public park isn't a desert landscape. This is what extreme modern heat looks like in areas completely unaccustomed to it. It's the literal physical manifestation of those vertical graphs we just examined. So I want to leave you with a final thought to chew on from this explainer. If natural cycles grant the Earth tens of thousands of years to adapt to change, how will we manage the unprecedented shift we've caused in just a single lifetime? As we've explored today, nature operates in 90,000-year rhythms. We are rewriting those rhythms in a mere 40 years. It's a massive challenge, and understanding this data is the very first step to facing it. Thank you so much for diving into the evidence with me today.